Sketch a graph of g of x equals negative 2 times the quantity x minus 3 squared plus 4 as a transformation of the graph of f of x equals x squared. Here we have several different transformations that the function must undergo to become the new function. So let's look at these one at a time. We start off with f of x equals x squared. We can change this into x minus 3 squared by replacing x with x minus 3. And this ends up being a shift to the right by 3 units. Good. Now we've got the inside of the function worked out. We have to deal with the outside. What's happening to x minus 3 squared to change it into this whole thing? Well, first it needs to get multiplied by 2. So this is going to turn into 2 times x minus 3 squared. And we can do this by replacing, replace our function with 2 times the function. We're basically multiplying this function that we had in this step by 2. And doing that is a stretch vertically by a factor of 2. So stretch vertically by 2. Then we take this new function that we have, and we recognize it needs to be made negative. We need that to be a negative 2 times x minus 3 squared. And the way that we get this is we replace our function from the previous step with the opposite of the function. And when we do that, that is a reflection about the x-axis. So we reflect about the x-axis. And then lastly, to get from this to our final function, negative 2 times x minus 3 squared plus 4, we need to replace the function from the last step with the function plus 4. We're taking this and replacing it with itself plus 4. And we know that this is a shift upwards by 4 units. And this is the function that we're going for. So in this case, we have 4 different transformations that the graph needs to go through. It needs to be shifted right by 3, stretched vertically by 2, then reflected about the x-axis, and then shifted up by 4. I'm going to do this one just a little bit differently. I'm going to look at the points that we have, the main points on this graph, one at a time. And for each of these points, I'm going to take it through all of these transformations one at a time. So what I want to do here is I want to start off with the origin. Now the first thing we need to do is shift this to the right 3 units. When we do that, it moves right here. Then it needs to stretch vertically by a factor of 2, and it needs to be reflected about the x-axis. But when we've got something on the x-axis, stretching it vertically and reflecting it across the x-axis don't change it at all. So it's going to stay where it is for those 2 transformations. And then lastly, it needs to shift up by 4 units. So when we do that, 1, 2, 3, 4, it's going to end up right there. And so we're going to have the origin being shifted to that point. Let's go through and do this with the other important points. Let's look at 1, 1. This is our next point. First, we need to shift it right 3 units. So that's going to be 1, 2, 3. And it's going to be at 4, 1 now. Now we need to stretch it vertically by a factor of 2. Right now it's 1 unit above the x-axis, so we need to stretch it so that it's 2 units above the x-axis. It's going to go right here. Then we need to reflect it about the x-axis. So at this point it's 2 units above the x-axis. When we reflect it, it's going to become 2 units below the x-axis, which is right here. And then the last transformation is to shift it up by 4 units. So when it's here, it goes up 4 units, and it's going to end up being right here at 4, 2. That is its final destination. Now let's do the same thing, but let's look at -1, 1. First, it shifts to the right 3 units. That's going to take it 1, 2, 3 units to the right here. Then we need to stretch it vertically by a factor of 2. So it's 1 unit above the x-axis now. If we double its height, it's going to be 2 units above, which is going to be right here. Then we need to reflect it about the x-axis. So instead of 2 units above the x-axis, it needs to go so that it's 2 units below the x-axis, right here. And then we need to shift it up by 4 units. So it's going to go from right here up 1, 2, 3, 4 units. And this is going to be its final place. All right, let's keep going. We've got this point right here, 2, 4. Let's put it through all of these transformations. First, it shifts to the right 3 units. So 1, 2, 3 to right here, 5, 4. Then we stretch it vertically by a factor of 2. So it goes from 5, 4 all the way up to 5, 8. It's doubled its height. Then we need to reflect it about the x-axis. So instead of being 8 units above the x-axis, it gets reflected all the way so that it's 8 units below the x-axis, all the way down here. And then lastly, we shift it up 4 units. So it was down here, we go up 4 units, 1, 2, 3, 4. And this is where it's going to end up going at 5, -4. Then we also have this point right here. Let's put it through the motions. We shift it to the right 3 units. We stretch it vertically by a factor of 2, so its height changes from 4 all the way up to 8. We need to reflect it vertically across the x-axis. So instead of 8 units above the x-axis, it's going to be 8 units below the x-axis. And then we shift it up 4 units, 1, 2, 3, 4. It's going to end up right here. Okay. We do have 2 other points, but when we put these through all of the motions, they're going to be outside of the part of the xy plane that we can see here. If we took this point 3, 9, we can move it to the right 3. When we stretch it vertically by a factor of 2, it shoots all the way up to 18. And then we shift it, before we shift it, we reflect it about the x-axis, so then it goes all the way down, to -18, and then when we shift it up by 4, it's still well outside of the part of the xy plane that we have. So what we're going to do is we're just going to use the points that we've got, and we're going to draw in a beautiful downward opening parabola. And this parabola is the graph of g of x equals -2 times the quantity x minus 3 squared plus 4, which is our final answer.